everybody. It's my pleasure to present to you Paolo Papotti, who is a professor in EURECOM. And previously, he was my colleague in the Qatar Computing Research Institute. And he's working on different areas related to databases, understanding data, and recently he has been working a lot on fact-checking, and in particular fact-checking claims that you can that are about statistics, right? And he had like a cool demo about that at the COVID times, and several publications on the topic. He was also a PC chair at the Truth and Trust Online conference at some point. And maybe without much ado.
Okay, thank you, Laszlo. Can the people online hear me okay? Yeah. Oh, good. Yeah. Okay. Good. Good morning. Good afternoon, everybody. I'm very happy to be here today. And today we're gonna see. I have the chance to share some of the work we did in my group over this topic of fact-checking. But before getting into the technical details, I would like to share with you a little quiz. I don't know if you can read it clearly. There are 4 claims. So I will encourage you to read them. Sitting too close to the TV damages your eyes. You should drink 8 glasses of water per day. Carrots are good for your eyes. And we only use 10% of our brain. So for the people in the room, is there anybody who believes that those are all correct? 3 of them? 2 of them? At least 1? So I let you the fun to do the exercise offline, but apparently all of them are false, according to my Google skills and investigation. And what is the most interesting piece is the one about the carrots and eyes. So this story comes from the Second World War, because the British Royal Air Force spread a rumor intentionally that the fighters were able to take down more Nazi planes because they were eating carrots so they can see in the dark. And apparently this was a rumor to cover the fact that they have a new radar system they didn't want Germany to know. So there was a very good campaign to spread this disinformation. Okay, so I like to start with this because this shows that we are all one way or another exposed to this problem, right? Even if sometimes we read about this, we think, okay, this is for uneducated people, or we dismiss it. But the reality is that it is a big problem and it's challenging, right? And I believe that some of us also spread some misinformation because you may remember that 2 years ago, when we were in the middle of the beginning of the COVID-19 pandemic, there was also this problem of the infodemic, they define it. The fact that there is a lot of information and it's not clear which sources are to be trusted or not. So, I'm guilty of saying it seems that we don't need to use masks because it's useless. I know that, it didn't age very well, but so this is a real problem, right? It is in the past, it's in the present. So this problem is, of course, nowadays, a problem that is amplified by the web and the social networks, right? And many people are pointing at them as the companies that should fix the problem. And we will come back to this, but indeed they are trying to do something. So for example, if you Google some sentences on, such as sun kills coronavirus, you will get different results as usual, but one of them will say that this is false according to the National Academy, and there is a link with an explanation. So they are trying to share some of these facts that are being checked. They try to share some of the outcomes so that people can be informed. On Facebook, they tried to prevent people from sharing stories that are known to be fake. So if you try to share something that is, they tried this, now they're not doing it anymore, but if you try to share this, they will tell you, maybe before sharing this, you want to check some alternative sources so that you can get more information. And so they will send the user to some fact-checking websites where people are debunking the story. And then this is the first tweet that got a label from Twitter saying, this guy is saying something that apparently is not really correct. So there is a link where you can get more information about this story. and they had some explanation. So all these ways of dealing with misinformation, with false claims, they rely on people studying the claim, sitting down with all the evidence in front of them, trying to come up with a report, a debunk report saying it is false or not, depending on what we know right now. Okay, so these people are actually organized in companies or in newspapers, NGOs, and there are almost 400 right now that are active around the world. So they do a fantastic job. They collaborate for sharing knowledge about the COVID-19 during the crisis. So I've been working with them. They are amazing people. I respect them a lot. They work very hard, but we're talking about less than 1,000, 2,000 people. So the big challenge here is that they cannot scale with the amount of claims, news, information that is created every day online. You don't have to take my word for this. There is a lot of evidence. For example, during the beginning of the pandemic, at Facebook, they have an army of content moderators, at the time 25,000, and they were struggling with the amount of claims that were coming up. There are many studies like this. I like this one because it shows that up to 22 days are needed in English for some claims to be identified and downgraded so that they are not shown to everybody. You know, they try to limit the diffusion. And in Italian and Spanish, some of the claims are never detected because those are languages with less resources. So there is indeed a big problem, right? And as people working in computer science, we try to find a solution to help address this problem. And indeed, this problem can be modeled as computational fact-checking. What we do is that given some content, in the most general definition, given some content, we would like to say if it's true or false, okay? So it is very generic. And indeed, people from all different communities have been trying to tackle this problem since 3-4 years now. So from NLP, databases, information retrieval, KDD, from all the different angles, people try to come up with different solutions. And in the last years, you know, the number of venues is just increasing and increasing. So today, I'm not going to try to cover all these different approaches. I'm just going to mention a couple of approaches because they are different from what we do, just to give you a feeling about the landscape. So for example, Preslav led a very interesting approach when it was at UCRI, where they claim that the best way to deal with this is to try to model as precisely as possible the different sources so that even before they write something, you know what are the sources to trust and the one that you need to be careful. There are many other approaches. Some other colleagues, they try to model the problem as a network. So they look at the spread to try to see the belief propagation. Those are also valid approaches, of course. In my group, what we've been doing so far, we have been focusing on something a bit more constrained, and it's the problem that given some textual content and some reference data, we want to assess if it is true or false and explain why. Okay, so I want to stress that again, this is different from other efforts because this is a big problem with different efforts, such as identifying what are the claims that are worth checking. Okay, we assume that we have a claim, we need to check it. We're not trying to match it against previous check done by, for example, the experts that I mentioned. This is a fresh claim that nobody debunked so far, okay? And we're not trying to model the trust of the sources. We assume that we have some data that we trust, okay? So there are some restrictions. I want to make it clear up front. And the goals are to be effective, as accurate as possible, scalable, because of the scale problem that I mentioned. And I like to stress this interpretability, because in the two works that I'm going to present, you will see that we try to, as much as possible, to motivate the answer that we give to the user. And this is because nobody will ever consume any of these if there is no clear explanation of why something is believed to be true or false. Okay, it is in the web interface that I was showing, there is always a link to see the explanation. So to be a bit more precise, what we want to build is a function that, given a textual claim and some structured data, is going to give us the label, some confidence estimate, and a description of the subset of the data that implies the decision. Okay, so today I'm going to focus on two kinds of claims. And you will see that basically we have different solutions for different kind of claims. And it is one of the challenges in this topic. I will talk more about at the end. But I will start with the simplest setting, which is property claims. So a property claim is a sentence that looks like this. Elon Musk is the founder of Chevrolet. Okay, so there are many, many approaches to take this claim and say that it's false. Okay, if you're familiar with the BERT, you can fine-tune BERT with some examples. It will tell you very, very quickly that it is false. However, in our work, we try to exploit this idea that we want to explain, right? So our system will take this property claim and tell us that this is false because Chevrolet was founded in 1911 and Elon Musk was born in 1971. Okay, so we claim that this is nice because it has some clear contradiction and also these notions of what is a person, a company. So this is something that people can consume and get a feeling of why we believe it's false. Okay, so this is a very easy example. There are some other examples that are a bit more subtle. For example, if I say Michael White alma mater is UT Austin, okay? Probably you don't know this guy, me neither, but he's a professor, right? And there's a claim stating that he got his diploma from UT Austin. Actually, the system for this one will say, I believe it's false because he's working there and he already has in our reference data 2 alma mater. So now, if you're a bit familiar with academia in the US, you know that it's a bit rare that you work where you got your diploma, and usually you don't have more than 1 or 2 alma mater. So you see that it's more subtle here, the information, right? It is not a clear contradiction, but we have some signals that reasonably give us an explanation. So how do we do this? First of all, there is a step to go from the simple property claim in English to is a structured representation. This is a triple where we have a predicate that describes the relationship between a subject and an object. Okay, so we have as input the claim and we have some reference data, as I mentioned. So for this work, we rely on a very specific kind of reference data that is called knowledge graph, and specifically incomplete knowledge graph. So let me spend 1 minute about this data structure. This is a graph where the entities are modeled as nodes and there are edges with the relationships. Okay, so it is very common in the semantic web to use these knowledge graphs. There are many of those. Some of them are general purpose, such as those coming from Wikipedia. Some of them are more specific to companies or industry. There are many of them, okay? And they look a bit like this. They contain triples as the primitive piece of information compared to tuples in databases. And for example, Barack Obama is married to Michelle Obama. He has a birth date, a birthplace, so far and so forth. So there are millions of those, okay? And I want to report this table because there are different knowledge bases, knowledge graphs, as I mentioned. They can be big in terms of instances, but what is important for my talk today is to stress that they have a lot of types for the entities and a lot of types for the relationship. So they're very rich semantically and they're curated. So they have a lot of information that is trustable and it's very rich in terms of semantics. You will see that it's very important in a minute. But on the other hand, they are accurate, they are rich, but they are incomplete. This is by default. So if you're familiar with the databases, we have the closed word assumption. Whatever is not there is false. For knowledge graph, it's the opposite. We have the open word assumption. So if I say Paolo worked with Preslab, Paolo and Preslab are in the knowledge graph, but there is no edge, we cannot say that it's false. We know that it is not there. It's because it's false, it's because it's missing, we don't know. So this is called the open word assumption. And it's very important, right? Because for our fact-checking task, if I say Paolo lives in France and it's in the knowledge base, that's easy. What is interesting is Paolo worked with Preslab and the edge is not there, okay? So how do we tackle this problem? So how do we say that something is false if it's not in the knowledge graph, okay? So let's look again at the output, right? We have that the alma mater for Michael White, I said that is false because there is this evidence in the knowledge graph, right? So that he works for UT Austin, he already got 2 alma mater from something different from UT Austin. Now the big question is, How do we know that it is the right evidence? Imagine that this guy may be connected to hundreds of triples, right? So how do we know that this is the good way to claim that it's false, right? And here comes the technical detail that is a bit interesting. We're using approximate rules over the knowledge graph. So this knowledge graph, they don't come with constraints, okay? But if you are able to discover these constraints, logical constraints, for example, if you have two alma mater in the knowledge graph, and they are different, Y and Z, those are universal variables, those are predicates over the knowledge graph. We're saying if a person has two alma mater, there is a small probability that is an error, okay? It's a soft constraint. If a person is working in the place where he got his alma mater, there is a bit more probability that there is an error, okay? So there is the contradiction symbol. So you see these logical rules are giving us some hints about things that may happen, right? And I want to stress that it's important to be approximate because in reality, the rules that are 100% certain are very, very few. I'm going to give an example in a moment, but most of them are like, if two people live together, they are likely to be married with a certain probability, but it's not 100%, right? So we need to model this uncertainty. Now the problem is, how do we get those, right? How do we know that they make sense? So we have a paper that I'm not going into details, just to give you a feeling, that is able to mine these rules, and we have online a corpus with 12,000 rules for DBpedia, where we show basically rules like this, right? If a person has a birth year that is bigger than the founding year of a company, and we claim that this person is the founder, then there is a contradiction. So now you see the pieces coming together, right? Someone comes with a triple saying founder Chevrolet Elon Musk. We go over our rules, we collect all the rules that contain this predicate, and now we can say, look, I found that this information is in the knowledge graph. So the semantic of the rule is telling me that with 90% probability, at least one triple there, it's incorrect. So if I trust these two, it's likely that it is false. Okay. So we call them negative rules because they identify these inconsistencies. And there are many of those, right? So as I mentioned, some of them are perfect, right? So if you are the president of the United States, you cannot be born in a place different from the United States. So far, this is true, despite the rumors on Obama, right? So this is certain, but there are very few of those, and they're very narrow. For general rules, you are likely to have some approximation. So far, so good? Okay, excellent. So those are online. If you need them for any project, feel free to reach out, but they can be downloaded. Of course, we are not the first to do this. I mean, we're the first to look at contradictions. There are also other rules that we can plug in our solution. For example, to handle a bit the problem of incomplete data. This is closer to link prediction if you want. Things saying that, you know, if you have a child in common, you are likely to be married. So those are rules that we also mine and put into the solution, okay? If you are the author of work, you are the creator, you know, there are different degrees. Other people have been playing with this problem to gather these rules, okay? So now you have all the ingredients to see our system. Basically, this is the input. We have an input claim C, the knowledge graph. I'm not going to cover the web stuff because it's not very important now for the sake of time. And the way that it works is that there is a system that will collect the rules, the claim, and will come up with a probability for the claim of being true or false with the rules and the evidence that have been used to take the decision. Okay? So more specifically, what we do is that for the given claim, we gather the rules either by discovering them or taking them from the corpus. We gather the evidence from the knowledge graph to instantiate them together with this triple. Now we collect all these rules and all these pieces of data. And an interesting aspect is that some of the rules may be supporting the claim, some of the rules may be refuting the claim. That's perfectly possible because they are approximate, right? So what we do is that we rely on a probabilistic extension of answer set programs in order to handle weighted rules in a reasoner. So we go to a reasoner with all the rules, and we ask the reasoner, it is more likely to be false or it's more likely to be true. So we take the one with higher probability and we put it in the output. Okay? So we have, of course, experiments. I'm not too interested in getting into the details because we show basically that compared to some baselines, such those going online to get in the evidence, link prediction in the knowledge graph, we get comparable or better results in terms of accuracy. But what I want to stress here is that it's the only method that will give you this. So we'll give you an explanation according to the rules that are used. Any questions so far? Excellent. Okay, so I can move to the second part. So we have been looking at textual claim data. We're going to keep this setting, but now we're going to look at a different kind of claims that are a bit more challenging, that are statistical claims. So look at this tweet from the beginning of the pandemic. There was a person supporting the government saying, this is not a big deal, the death rate is not really that high, it's much lower for the COVID-19 and, and some other things interesting. But what I'm focusing here is that this person claimed that the death rate in the US in March 2020 was 1.3, right? So this is something that it's, at least as human, quite easy to check, right? I mean, you can do the math and say, oh, look, it's not 1.3, right? Or it is. So assume that we have a table, some relational data, where there is the country, the number of deaths, and the number of cases. The simplest possible data set for this claim, right? Now, the approach that I just introduced, unfortunately, here is not going to help us. Because remember that there we have this rich knowledge graph with a lot of predicates. Here you see that it's a relational table. I'm a database guy, so I love relations, but it's quite poor in terms of semantics. We just know that these things are related, and there are not many rules that you can get from here. You can get the rule, the deaths are always smaller than the number of cases. Okay, you can debunk one kind of claim, right? But there is not really much that you can say from this kind of data. So we wanted to find something different from this problem. Another challenge is that there are many values that are not appearing there and they are derived. So we cannot just look up things to say, oh, this value is there or it's not there. We have to derive them. Okay, so it is much more complex. So we tackled this problem in 2020. We created this demo that Preslav was mentioning, Corona Check, in order to verify any claim about the effects of COVID-19 and in terms of statistical claims. And basically, this tool will say that this claim is false because going over the official data from the government, so again, remember the assumption, there is data that we trust. Now, we can get into a debate, do you really trust this country data? I don't want to go there. I'm saying, assuming that you have some data that you trust, or the best data that we can gather, we can try to interpret this and say, I know that I need to look up over the table. Oops, sorry, it's a mess. Okay, the table with the total deaths, I'm interested in some rows and some attributes over these two tables, and you need to combine them with a division. So the value that you get is 2.8, which is different from 1.3. So you see that, again, we are trying to be as much as possible interpretable and say, I believe it's false because of this data. Okay, so this demo was online now for quite some time. People use it, so we were able to gather real claims. And it's an interesting problem because, as I mentioned, we can use the real data, and we assume that we have the textual claim again, and now relational tables. And we have a claim that comes in the form of a comparison with some operators between the value of a certain query and a parameter p. When Q is executed on the data, we want to see if there is at least one query such that will return that value. Okay, so some cases are simple because this P is explicit. The number of new cases increases 100%. So P is 100%, it's relatively simple. Some cases are much harder because people can write things, unfortunately they do. The number of deaths increased in March in France. So it is much more subtle because there is no number, or the number of deaths increased a lot, increased slowly. People can be very creative, and what is the right way to check this? I will come back to this in a moment. Okay, so if we cannot find any query that justify the claim, then we say there is no query, so the claim must be false. And you see that here, I'm really exploiting the closed word assumption. I'm saying if it is not in the data, I cannot find a query, then I say that it's false. This is in contrast with the open word assumption that I used earlier. Okay, so the kind of data we're using really has an impact here. So the challenges are at least two. One is that the number of possible queries is big, and then we can have some spurious match. So let me show this by example. Imagine that I am looking at this data. There are many queries that I can generate, a big space like look up, ratio. So we can go on with the average and count and things like this. And also, it's possible that 1.3 comes from some spurious correlation in the data. Like if I divide 130 by 100, I will match this value. But we don't want this, right? Because it would be incorrect. So this motivated us to use some NLP techniques. And specifically, we built something very simple. We have templates for queries. Then we fill up these templates with information coming from the claim. And specifically, we try to predict, given the claim, the relations that should be involved, the attributes, the tuples, the formula. If the P is easy to parse, we will parse also the P, okay, the value. So we gather all of these, and then we combine the top K prediction in order to build the queries. We build the query, we do query generation, we look if there is at least one query. If it is not there, we know that it's false, okay. As I mentioned, this gets tricky because we are making assumption on the things that we know, right? So we know some of the formulas, we know some of these values, right, coming from our data set. But in many cases, people can be creative and come up with things like the number of new cases in France decreased a lot. So our system will say, I know that it's this table. I know that you're talking about these dates. You're talking about France. I know that you need to use this formula, but what does it mean a lot, right? And another example, in Europe, the number of new cases is decreasing this month. You see that our system will understand that it's less than 0. Other metadata, but what are the tuples? We don't have Europe, but we have Italy, Tokyo, Paris. So we need to learn this, right? So we did this with a very natural approach, that is to ask the users to tell us what they meant when we don't know. Okay, so we were gathering examples with active learning from the users, and we show in the paper that we can train the system with their annotation, and it works. Okay, so this is something I believe nice. And this is for the scrutinizer, the bigger system. And actually, this system was designed in 2019, not for the coronavirus crisis, but for a different problem. And that's why it is a bit more complex than what we saw. We saw this module that is the one in charge of the query generation, but we have also a module where we try to involve a crowd of users, multiple users that can do this verification. Because indeed the story started in a different domain, and I report this because there is an interesting insight. So in Paris, there is an agency where they write every year a big book that goes on the desk of all the prime minister in Europe, US, Canada. And this book contains all the information about energy, prediction, climate change. And the problem is that they need to verify the book because the number, the prediction, they change over time. So right before publishing, they need to verify every claim in the book. And it's a lot of claims. We're talking about thousands of claims. So they collaborated with us and told us, you know, we have this problem. And I told them, yeah, I mean, we can try to assist you. So we built a tool to help them in the debunking of the claim on their database. Very similar to what you saw for the Corona check. So I like to report this because it shows that given the same set of claims in 20 minutes to two groups of people, one using the old technology, Excel and the SQL, one using our tool, you see that in 20 minutes, the number of claims that are verified by the people using our tool, it's more than double the number of claims checked by people using SQL and Excel. So we like this because it brings some evidence that we can indeed really support people, okay? I'm not claiming that we're always correct. there are cases that are incorrect. I'm not claiming that it is a fully automatic solution that will solve all the world in fact-checking, but there is some evidence that this can help people, even when claims are complex, with complex rules and many cells that are involved. You see that our system is quite consistent in the time needed for verification compared to manual. Okay. Any questions so far? Okay. So we have been working on this for quite some time, and the Press Lab did also a lot of work, and other colleagues work on this. And finally, at some point, we met virtually, and we decided to write a bit about the status of this computational fact-checking problem. And indeed, in this paper, we have also people coming from fact-checking organization. So you see that we have some solutions that cover some of the problems that are there, right? And so in this paper, we discuss a bit the status of the systems, if they're ready for adoption, and there are some interesting insights that are promising. However, I want everybody to be aware that it is a problem that is much, much bigger than what we can do with computational fact-checking. And the reason is that it is a societal problem where humans are involved. So why humans are so tricky? So this is a picture from Facebook, where the guy was, stopped when he was sharing his ideas, because they were saying, look, what you are trying to post is in contradiction with this science feedback article saying that, about the vaccine, they do not cause some disease, okay? And the guy saw this, and, Facebook stopped me with this pop-up. This is their tactic to stop vaccine truth. Pretty pathetic. Do they really think that I will read their pop-up and believe it after my years of research on vaccines? So you see that it's complicated. Another person, thank you, Facebook, for being so concerned. Give me a break. You really think I'm going to trust you? And my favorite is a guy giving tips on how to stop these fact checkers to bother you with their recommendation of what is correct or not. Okay, so I think that it's interesting to be aware of this, right? I mean, as a computer scientist, we are pushing the technology, and it's a valid approach, I'm sure, but it's clear that there's something bigger in front of us that goes beyond what we do with our claims and verification. And I like to conclude with a bit of an analogy with another societal problem that we are all aware and that we are all been fighting for some time. So there are many plots here, but just focus on the red line for a second, please. So this is the number of deaths for car accidents per billions of miles driven, okay, with cars. And it starts from about 100 years ago to today. And you see that this is a big societal problem because people want to drive. They want to do whatever they want to go around, and you can't tell them, no, it's dangerous, stay home, right? But over time, we have been able to go down significantly. I mean, it is still a big problem, I'm not denying this, but compared to 50, 60 years ago, we are doing much better, right? So what is the analogy here? That, of course, this line is going down because of people like us, engineers that designed in the 70s, the ABS for the brakes, or the safety belt in the 60s. Okay, and but there is much more. There is also the people who came up with the rules that safety belts are mandatory. In New York, this was in 84. In Italy, I was a kid, so probably in the 90s. So this is something that needs also the legislator to be involved. But there is more, like, there is, if you don't put your seatbelt, someone will stop you, will give you a fine that is regulated. If you do something dangerous, you will go to jail. There is a jail with clear rules. So what I'm trying to say here is that in order to reduce so dramatically the number of car deaths, there are the engineers in charge of some of the components for the safety, the passive safety, right? But there are also the local government taking care of the road and the people taking care of the street, checking. There is the legislation with clear rules on at what age and after what training you are able to drive, right? We all go to social network and we can do whatever we want after 12, right, officially, but you're not certified that you know what you're doing. Okay, we can debate about this, but the analogy is that here to drive, you need to be certified, right? So what is the solution for our problem, right? In a way, I believe that what we're doing with our coding is to build computational fact-checking, and it's like doing the airbag. Do we claim that it's going to solve everything? Not, of course, right? There are more technology, different approaches, and they're all going to be needed. But also we need these guys. This problem is big because nobody knows exactly who is in charge of what are the roles, what are the responsibilities. So last year, finally, we started to have some regulation coming from the European Union, from UK, now they start also in the US, to give some ideas of who is responsible for what. As a platform, what do you need to provide to people to check what you're doing? What are the problems that you can find, the fines that you have to pay? So this is all under discussion, and slowly we're getting there. Okay, so to conclude, I think that I like to stress two things. Of course, there is a lot of technological improvement that is needed. In my group, we are focusing on two aspects. One is the ambiguity of the claims. I didn't go over this in the presentation, but unfortunately, a large number of claims coming to our system are like the number of cases is going up. Okay, is it in Europe, in Italy, in France? Is it today compared to yesterday, or this month compared to last month, or this year compared to last year? So you see that I have at least 12 possible interpretations for the same claim. And what we show in the demo, if you try, is that depending on the interpretation that you take for any of these dimensions, you will get a different outcome. That rate is fatality rate or mortality rate. It's very ambiguous, the language, and people are not very precise usually when they write. So this is something that we are doing. We are trying to create better explanation that people can consume, and you know, other people are doing other efforts using multimodal methods to include also images. This is all good, and we will keep pushing. But I hope that I give you a feeling also that it's not only about our work, but we need to be aware that we need also regulation and education if we really want to take this problem. So I think I'm on time. So thank you so much for your attention.
Okay, questions?
Yeah, you mentioned that you got this review about production-ready fact-checking systems, right?
Sorry, say it again?
You mentioned that you had a review of fact-checking systems previously, and what is like the main outcome of that? Like, what is probably the best production-ready system right now? Maybe which I can, for example, can use by pulling something from GitHub. Is there something good library framework?
I see your point. So I will give you my answer, but I'm curious also to your comment, if you want to comment on that. So my personal answer is that there is no such system right now. So there are different efforts, and I presented two. As you saw, they are decent. I don't want to say they are perfect, but they show some promising results for some kind of claims, and the second in some domain. So it really depends on what are your requirements and assumptions. So if you say I want to claim, I want to check general claim about encyclopedic knowledge, I can point you to one system that will be effective. But if you want to verify some claims that are some specific kind of news in a certain domain, it's different, right? There is not one system that will fit all domains and all kinds of claims. What do you think?
Okay, so what do you think? There are several, many papers have their code released, right? So, for example, and you can just go and try them. I mean, I agree with Paolo, there's not one system. And fact-checking is done in different ways. So you can do fact-checking with respect to some tables, right? This is what more or less Paolo is doing. There are several other people that are doing this. This fact-checking against Wikipedia, this is Fever. More recently, people have tried to put those two things together. For Fever, there are systems that you can actually go and try. I mean, there are demos that you can try. I mean, there are several demos. In my group, we have developed several demos. Paolo has developed several demos. But it's kind of true that, you know, okay. And actually, some of those systems, you can even find them in Hugging Face. For example, for something called propaganda detection, right? And several other things. So it's not that they are not systems, there's not a universal system, kind of something that,
So-
that you take and to say, okay, this you
So there is a
specific way.
baseline.
And then there are systems, for example, Google has a system to search the claim schema where you can go, but it's probably not exactly what you want. And it's more like keyword-based search. I mean, you know how Google search works, and then it's going to give you claims that are somehow related to those keywords that are previously fact-checked. So, and this can actually kind of help you, but it's not exactly like there's no system where I can go and upload this document. It's going to tell me what you have shown. This claim is false, and here's the explanation. There are different depths, but there's not one universal.
There are always some assumption. There are, I mean, this is from a different presentation. I just want to show it because it is related to what you said, right? So here we are comparing, we have 2,200 tweets from which we have the trustable label. Okay, we know that's false or true. And we compare two methods that are from the literature and one method that is using birdwatch, which is a bunch of humans on Twitter. Okay, this is an initiative from Twitter. And what I like to show here is that you see the humans, they can agree on a large number of claims with the ground truth. I mean, they are able to converge to some ground truth in most cases. But you see the computational methods, you see the number, it's quite low, right? And I don't want to blame these people. I mean, those are colleagues that they did excellent work. The problem here is that in many claims, those are tweets. They really cannot say because they are trained on data that is not tweet data. So, you know, we're breaking the assumption of the distribution of the data. So it is not really fair for them. But the reason is that really it depends where you come from, right? If you say, oh, I have a piece of text about, you know, common things that are well known, any baseline built on top of BERT with fine tuning with the pre-trained language model will give you decent results. But when you get into, you know, you step out of the reasonable cases, you go into tweets, for example, the system falls short. Does it answer your question?
Well, yes, I think that, yeah, sure. Because, well, I'm always looking for something like a solution, like a Hugging Face transformers where all things are collected, but if there's no such system for this thing, then probably that's fine.
So we had a discussion yesterday about this problem, the fact that it's very difficult to have something like Hugging Face for anything else, right? And I think that there are some reasons. I mean, mostly money, I guess, because of Hugging Face, they must be making money somehow. Sure. Any other question?
Yes, from online. I have one question. Can you hear me?
Yes.
Yes, thank you very much for the informative talk. My question is on the active learning part. So in the COVID news system, you mentioned that you've used active learning. I'm interested to learn more about the model you've used active learning with and how exactly did you handle things like class imbalance? Any more details you can give on the system? Thank you.
Sure. Yes. So in the system that we have online, we don't really do active learning in the sense that those are claims that are coming from the people, and when we don't know, we ask. We did some experiments with active learning. I was not very precise here, sorry, but in the other context, the context of the claims here, because here there is a big problem that we found that if we do active learning in a way such that we want to maximize the utility of the example in order to improve the model, we were giving a big headache to the poor fact checkers, because you can imagine that the claim that are giving you the best information for the annotation, they can be sparse over the document. While for them, it is much, much better if I ask questions that are in the same paragraph, for example. So we have in the paper a section where we explain how to balance these requirements to try to get as much value as possible from the example that we show when we learn, and try to also keep them coherent with at the level of the paragraph and sentence. Does it answer your question?
Yes, thank you very much.
Yes, thank you so much for the talk. My question is regarding
So based on my assumption, like property claims and statistical claims are backed by some universal truth, right? So your accuracy will be as a function of the thoroughness or exhaustiveness of the knowledge graph and the authenticity of the sources and maybe the statistical data sets. However, with like non-universal truths that are more like scientific claims, let's say applying olive oil will help reduce hair loss, right? There's no like real like universal truth behind that answer. So the claim will have to be basically backed by some research, and you might have several contradictory research papers regarding that. Like some controlled study that proved that there is an improvement in hair loss, and another one that's more maybe randomized that proved that does not help as much. So how would you handle non-universally backed truths, if you can?
Yeah, I mean, you're looking way ahead of where we are now.
Yeah.
As I know. So, yeah, I mean, there is no straightforward answer, I believe, right? So one partial answer that is not going to make you happy, but one partial answer is that for very complex claims, sometimes there is, especially the ones that are popular, election, health, there is somebody who took the effort to do the checking already, and he brought something. So he mentioned that one approach that I didn't show today is that you assume that there is this big corpus, 100,000 claims. Yeah. You have a claim coming, you can try to match. Yeah. So if it is something that it cannot be done this way, you can try to match over this corpus, and if you're lucky, you have a match. This will help you. I know that it's not gonna, it's not what you want to, but I mean, this is one way to get out of this, right? And I think it would make sense for such claims to be inherently false, to be considered inherently false or not substantial. We don't have substantial evidence. So let's say any claim like applying something to your head will improve hair loss should be considered false until proven true. I see your
substantial evidence.
Let me comment on this. So in this work, and when you talk about computational fact checking, we focus on the factuality of a claim. Yeah. That's kind of the easy game. Yeah. There are some games that are even harder, such as how harmful is this claim? Yeah. It is very important for fact checkers and people working in this domain because they need to prioritize. How do I know what are the most important? I mean, they need to read and think, right? But if you have 1,000, it would be nice to rank them. He has been working on other dimensions that are like, is this containing propaganda? Yeah. Is this, there are many aspects that are a bit more subtle than factuality. Yeah. They are all important. Yeah. So,
thank you so much. Sure.
Other questions? Oh, thank you very much. So I have a question more on the knowledge graph side. So as you just mentioned, in knowledge graphs, you may have missing links, right? So some relations are missing in the knowledge graph. So I'm wondering whether you are aware of any works on, say, knowledge graph completion or knowledge graph compression, because this way you may want to make it more complete, relevant to what you want to discover. So if you know some of the works, could you please comment on that? Thank you.
I see. Let me think a second. So for our work, we compare with a simple link prediction method that tries to check if the link we're interested in is existing or not. And I don't remember the numbers, but again, this was a naive method from 2019 or 18. So I'm sure that now with GNN, they do much better. So, but just to give, for curiosity, I don't remember the numbers. Here. So this KGM is a link prediction method, and you see that it's doing fairly well, and it's the top one in one case. This is the link prediction over the graph. So that would be also a valid approach, but in my experience, at least this method and the few that I saw, they are black boxes. So that they tell you the link is there, is not there, but they didn't give you what we claim to be an interesting explanation.
Got it. Thank you very much. Because actually, we are trying to see whether there's a way to see how links are generated from other basic links. Then this.
So you can claim this as an application.
Thank you.
Sure. Yeah. So I wanted to pick up on this gentleman's question before. So many things, especially in the field of medicine, which the general public takes as fact, are based in fact on a balance of evidence, right? So I was just wondering if instead of coming up with a true or false, the system could be trained at some point to say this fact is based on a balance of evidence and is probably worth checking via other sources rather than blindly accepting.
Yeah, so in the other project I was mentioning, we tried something similar. That is to say, can we estimate how complex it is to check this claim? That can be a proxy for what you are asking, right? I mean, can you say that there is enough? If I understand correctly, you're saying, is there enough material to say something meaningful? Would you agree?
Yeah.
Yeah. So we failed. Sorry. So we didn't find a strong signal to say this claim is to characterize it as easy or hard. We tried with some properties, we didn't find it. The alternative is that you try to debunk it, and depending on the confidence of the model, you say I'm confident, I'm not. But we were trying to find something a bit more elegant, more principled than just applying the model. Because the shortcut is just apply the model with what you have and look at the score, right? But it's not a great solution, to be honest.
Thank you.
Sure.
The questions?
Online, maybe? No? Okay.
Okay, I have a question. So, kind of you are addressing claims that have very specific form. So, how far can you push this? What is the limitation? If you want to extend this, what do you need? Do you need kind of more templates? Or do you want to go beyond tables?
Yeah, so in the models we're focusing now, we try to be multimodal in a very limited fashion, in the sense that we are trying to extend them to consider as input structural data and textual data. The problem we have with the current model that we're building is that we are missing some of the interpretability. So, we are after this trade-off where we make more powerful model that can do more general analysis in terms of the assumption over the claims, but at the same time, we can be quite clear in what guided the model into the decision. This level of clarity, so far we're not able to achieve it, because the moment we have text and structural data, what we're using are methods based on encode everything and use it in a pre-trained language model. So we are able to debunk with decent accuracy, but the moment that we go into the classifier of the pre-trained language model, we are losing the ability to understand exactly what's going on.
So when you go in the language model, how the prover fit there?
Say it again?
The prover, kind of, which is part of your solution. You have a logical prover, listener. So kind of, how would it feel when you come to use language models?
So, as you know, we tried to teach to a pre-trained language model to do some reasoning, right? But we tested it, and it is very brittle compared to the reasoner with the proper facts and everything. So brittle in terms of accuracy, in terms of confidence scores. So it's not there yet. So if we get to the point where we have pre-trained language model that can reason effectively, then you can take this and expand it very nicely, because you will have much better language understanding, which is a big limitation here, right? So I would say that would be a nice component to have.
Another one question. So thanks for the interesting talk. Just wondering, is there any common framework for the fact checking today? Because I see you discarding like no evidence level for this fact checking case. What I can understand from these presentations, in your experiment, you have two classes, absolute two classes. Like
no, good point. Sorry, I see your question. You are saying, do you really have only two labels? It seems a bit restrictive, right? No, indeed there are more. Usually there are three in the systems. In the more advanced systems, at least, you say support, refute, or
like paper.
Not enough evidence.
Yeah, like paper data. So
yes, exactly.
We got three levels, right? Like refuted and
Yeah, in these works, we didn't chase that case, but
is there any reason you exclude no evidence or no support?
say it again?
Is there any reason or motivation to discard the third level here, which is neither true, which is neither true nor false?
Yeah, I mean, we just didn't do it in this case. I mean, we're focusing on a simpler setting, but in many data sets like fever, feverus now, and there are more and more 3 labels. So the new models we have, they also consider this. Yeah, I mean, they're not enough support, to be honest, in my experience. It's very hard. It's very hard because the model gets confused between the cases that are false, the cases not enough support. It's very difficult. I don't want to start a discussion even for humans because I never thought about it seriously, but it's difficult to say, right?
Yes, true, I agree. The reason I'm asking is because like if we think about it, like in the real world scenario, when we want to apply fact checking, we know that the knowledge is always evolved and claims always happen, right? So I'm thinking like, because you mentioned the claim is always ambiguous and we always have time attribute there where the knowledge we have in year 2000 is different with year 2010, and the claims also evolve, right? So that's why I'm thinking like we always need to have a third level, which is it cannot be proven with the knowledge of year 2000. Yeah, as far as you know, because I'm pretty new in this fact checking research. Like, is there any research that what people have done in this field, like especially doing the timeline-based fact checking, where we have evolved, like knowledge, using different knowledge or using different claims, and what will happen with the current state of the art things?
I think that would be a very interesting experiment to take something like fever and show it with different corpus of Wikipedia over time over the different years and observe with the same method, the same set of claims, how much time is helping. Just as a basic experiment to go in that direction, right?
So we assume there is a...
No, I'm not familiar with this. Do you know anything about this? No. So if you want, I don't know, are you a student?
No, I'm a master.
So if you want to write a paper on this, maybe it's a valid direction.
So these fact-checking systems, can they be personalized?
Yes. So to the extent, for example, of to these 2 that are presented today, but in general, yes, it depends a lot on the data that you provide as the corpus of reference.
Is there a way to learn the facts actually from the data? Like this Google, like Google Assistants, Siri, Alexa, they used to listen to the conversations of the person regularly, right? So is there a possibility to extract facts from those data points?
So you're making me very happy because it's something that we are doing now, and we find it very promising, where basically we try to show that you can do fact-checking in the setting with the structured data by bootstrapping the system only with examples coming from the data. So we don't have human examples, and we show that the examples we generate, they get you an accuracy comparable to the example written by humans. I think that it's close to your intuition, right?
Yes.
So, yeah. I mean, just a comment. There are already some papers where they are doing this by using GPT. So they show that for text classification, you can write very simple templates in GPT. They will create for you a lot of examples. And it's very nice because they do things like, given a sentence, then there is the prompt in other words, and this will give you a sentence that is, like a paraphrase. Or you can put, given a sentence in contrast, and it will give you something that is opposite. So you can create a lot of text examples for target application, and they show that in standard benchmark, they can improve the results.
But are those examples always true? The examples
in this paper that I mentioned, yes, because they don't target fact checking. They look at other tasks with the NLP task where you have text and classifiers, but it's the same intuition that you. So this is very important because you are touching on a big problem that is, yes, creating true or likely true sentence is one thing. How do you create good training data for false sentences? So that's one part of the research we're doing.
Thank you.
There was another question.
Yeah, I just wondered about the cultural differences. So I think you described some rules at the beginning about the alma mater question. So
Yeah.
one of the rules that you described was in the United States, it's not usual for a person to work at their alma mater, but maybe in other parts of the world it is common practice. So how would you?
It's almost mandatory that you take the job where you know people.
For example.
It's all about connection. Yeah, I see your point. Yeah, so these rules are biased by the knowledge graph we use to mine it. So this knowledge graph, it's DBpedia in this case, which is structured data coming from Wikipedia. So they are general purpose. Now, we are aware that these rules, if you make more conditions, they are much more precise. So because we make them conditional. So we have a follow-up paper when we try to extend the rules with more conditions, like the one for the president of the US. Now, this is a bit problematic because if you try to be more precise, it's good because the rule is more accurate, but the scope of the rule is much smaller. So the number of cases that you cover is smaller, right? Because you have more conditions. It's more narrow. You see that the rule with the US, it applies only when you have someone that is president of the US. So it's more narrow in terms of coverage. So you need a much, much bigger number of rules. And this becomes a bit of a limitation and a problem to handle. But in principle, it's a good path, right? I mean, you want to make them more precise, but it's not so simple, right? Like the example, if you are married, I mean, I give you another, no, maybe not. Another example is if you're married, if you live together, you're married. In Italy in the 50s, yes. Until 70s, yes. 80s, 0.8. Now 0.5, right? So there are many rules like this that they evolve. And as far as I know, there is nobody trying to mine these rules with this temporal aspect. That will make sense, right?
Any other questions?
Thank you everybody for coming, for the nice questions.